My name is Heinrich Schuchardt. Yuning is the CEO of DeepComputing, who has really made it possible to really have a RISC-V device on your laptop, or as your laptop, and work with it every day. And the thing that I want to talk about in the first part is why did Canonical decide to move the ISA from what we had before to RVA23? And in the second part, Yuning will present how this translates into the hardware story. So why did we need an ISA upgrade? So in 2010, at Berkeley, RISC-V started as a university project, and it was enough to show that you can build a microcontroller with it. And in 2018, there was a first board that was really able to be ported to Linux, and it had just the essential instruction set that's needed for it, like integer instructions, floating point, and that's it. And if you compare to other architectures, they were far ahead. So if you look at ARM and x86, having a single instruction, multiple data, or let's say vector operations was standard by then. Hypervisor was a standard that you would expect on a board. And also you would expect more security. The one thing is control flow integrity, which is really part of the ISA, but also things like IOMMU weren't even defined for RISC-V. So the ISA that we came up with when we launched in 21 our first image for RISC-V, that ISA is not really up to the standards that we expect. And this is why RISC-V International, the organization that was founded, I think, in 2015, to standardize the different extensions for the RISC-V ISA, took up their work. They had the first version of a standardized ISA, RVA20, that was, I think, in 22, they published it, and then they also published RVA22, which had more instructions like cache management, and also as optional vector and hypervisor. So that was a step forward, but already in 22, everybody was telling me RVA23 will be the thing that everything is converging on. And with RVA23, now hypervisor and vector operations are in the mandatory set. In the mandatory sets, there are things that are needed for enabling some expansion options like control for integrity and a lot more. And I just picked out 4 of them. So the one thing is increasing performance via single instruction, multiple data. So we have vector instructions as optional part, also vector crypto. There are extensions coming now for reducing the code size further so that one can replace some of the 32-bit instructions by 16-bit. There is an extension to improve energy efficiencies. So this wait on reservation set is, I mean, you often wait for a second thread to do something, and you can simply say, I just switch off the core until this memory cell has essentially been changed. And in security-wise, there are extensions now in the optional set for landing pads and shadow stacks, which really give you a control flow integrity once they are implemented. If one looks into all those hardware vendors that I have here, and I've not listed all of them, but at least all of these that are here on the board have said they want to move to RVA23, and there are even more that have said they were moving to RVA23. For instance, TensTorrent published yesterday that in second quarter next year, they want to have a dev board out with RV23. Or for instance, Damo, with whom we have started a partnership and announced it this week, is also moving in that direction. So all the industry is gravitating to RV23. And so when we had this decision, shall we wait for the hardware being out with RV23, or should we be at the forefront? It was easy for us to decide, yes, we should be at the forefront because the partners that we are working with are going to RV23, and for testing their designs on FPGA and on the upcoming boards, they need some distro that has RV23. So if you look at the timeline of releases, so Ubuntu 24.04 is the last release which will support the old hardware, which is just having RV64GC or up to RV22. And with 25.10, we now have the first release that requires RV23, which unfortunately means we are leaving the hardware behind with an LTS release. And currently, the current release runs on QEMU only because the hardware is expected beginning of next year. But next year will also be the first LTS release with RV23. And we will continue the support for pre-RV23 hardware with our Noble release. And we are still trying to bring new boards to that release. But for everything that's RV23, we needed that new release. And, oops. What is our experience with it? So my experience was it just works. There were very few bugs that we came upon when we were rebuilding parts of the archive. So there were 3 GCC bugs fixed upstream. There was one thing emulating some RV8 instructions on S390X mainframes in Big Endian didn't work. Okay, such things you'd only discover when you're really testing. And it will not stop here. So if one looks ahead, we are in the next cycle. We are investigating how we can enable RV23 for more languages than C and C++, so for Go, for Java, for Rust. We will start investigating what control flow integrity will mean. The promise is that if you have software compiled for control flow integrity and other software, it should run seamlessly together. But before enabling it for the distro, we will for sure test that it really does. And looking even further, there's a lot of work ongoing for matrix operations, which will further speed up AI on RISC-V. And that's it for the outlook. And now it's up to you, Yuning.
Okay, that's great. So for those one never heard about deep computing, and here we're trying to explain what we do. We only make RISC-V consumer electronics. And we start from the most complicated one, which is a laptop. So that's why for us, now the speed of us is from the chipset tape out bed to a mass-produced board. Our record is 4 months. So and this year, we're looking forward is RV23's chip coming back in December. We're trying to fix the kernel upstreaming. Then you will see the ball probably around Foxstorm timing. And we're trying to catch up the 2604's release. And then Canonical can probably the first one will get onto official building the best Linux OS image for RISC-V. So that is the roadmap. Doesn't work.
Harder. Press harder.
Harder? Okay. Sorry. So I'm a software guy. I earn all my money from my selling my software startup, and then I lose all my money on the hardware. so pretty similar to Mark, isn't it? Right? Anyone remember the Ubuntu phone? But we'll become again, okay? 3 times lucky. So I'm a software guy, and I used to do VM runs the Nokia platform or the feature phones. So we lose to Android is part of my fault. And then I do static compiler as well on my startup. And then DeepComputing is founded in COVID. I got nothing better to do, got locked up in Shenzhen and Hong Kong every 2 months. So we start doing the hardware because Shenzhen is hardware side. So I only can travel around Shenzhen. So we start doing the laptop. So deep computing is we focus on consumer electronics, and premium one we don't do cheap stuff. Right? That's why I don't do the one board. Sorry. So I need somebody carry around RISC-V the whole day. So the one board is not So the RAM will sit on the desk. So and I normally I get a chip, no matter how bad it is, how good it is. I try all the product segment. So I make 2 generations of RISC-V pack running Ubuntu as well, and then 1 generation of speaker. So I found out all the problems. And also the pack can call on Ubuntu, can make the call as well with external LTE modems. And then the most we famous about is making the laptops. So it's the most expensive laptop as well ever see. It's $5,000. So and more expensive than the Apple, or even the NVIDIA DGX. So, but it's 100 times slower. So, and sitting in the UK in Milton Keynes Computer Museum, National Museum. So, people will take a look. And I promised who had the buyer for it, and we got an NFT there. So, gonna worth a lot more. So and as I say, I'm a software guy, earn all the money, and then lose all the money. So I'm getting stressful. So I decided and make some toy cars as well. So I make the drone, and then let the government shut it down. So with the RISC-V on it. So that's power fun. And with Canonical is a kind of a very impressive journey. I still remember when I announced the laptop, I talked to the sales guy of Canonical, and they asking me for $1 million and wait for 9 months. And then I tell them I might be dead already. But I don't know how, Cindy, probably you know the story, but Cindy, I somehow come back out. No, anything for RISC-V, free. So, oh my God. So we get over it. So all the old 2003 4-core, I do my own laptop at that time, and then I refresh it with an 8-core 2024. They all running 2404 release. I find it very funny on RISC-V. At that time, the first generation running the 24, the first release is very slow. But you running the later on release is going faster, same hardware. So it's very different from Windows or Android, you know. And the old hardware with the latest software runs faster on RISC-V. It's very different. If we like Windows, usually, right, new OS makes the old hardware you cannot run, so that you buy new hardware, right? But on RISC-V it's completely different. So this is the time I make all these hardware myself and lose all the monies, because it doesn't scale, doesn't sell. Never reach to 1,000 pieces. So in hardware you don't make 1,000 pieces, you don't make money. So that is the time, 2004, we announced now a deeper collaboration with Ubuntu and Canonical. So we have a vendor kernel, and then Launchpad makes all the image. And then in 2005, 25, we partnered with Framework. I'm fed up of losing money of making my shell. So I focus on what I'm good at, making the motherboard, because we have a very good relationship with all the RISC-V SoCs. So, and more exciting, I think 2006, I'm going to fix the kernel upstreaming. We have a program of a RISC-V International, we call it kernel upstreaming program, silicon upstreaming. So we're going to do better than ARM. So I think there's a few ARM guys here, right? So we're going to do better than ARM with silicon upstreaming. So you will see upstreaming, we don't, even before the chip comes back. So after that, then Canonical, we will build the image officially for us, and accept probably GPU support. So that problem I cannot solve until I got enough money buy off a GPU and open source it. Probably Mark can do it. So, and then after that, you got a RVA23 hardware, Ubuntu official image, and you guys feel free to contribute to optimize all the RISC-V package. In RISC-V ecosystem, we have an organization called RISE. Why we call it RISE? Because I would say that it's part of the RISC-V rising. It's an unstoppable force. Because our slogan for deep computing, we make the best Linux PC. We don't make Windows, Android run on it. So we're going to open source everything from BIOS, ELK to UEFI to kernel upstreaming, everything open source. Probably we're trying to do it with silicon, so people can have a hands-on quicker. And then RISE have come up now. We build all the package. We got a term called MNO. Most the package are not optimized. So you guys, software guy, can help on all the optimization of every packages. So now, I'm frameworks partner with frameworks good because I make motherboard every 6 months. A new one, for example, now this A-core just announced with 50 TOPS AI, you can run large language model, 14B model on with 5 tokens per second. And then we finished porting on the VLC, support local AI, the subtitle translation as well. So that's the reason I don't want to lose money on the things it's nothing to do with RISC-V. So and then it's very good framework. I think probably half of the Canonical guy use framework anyway, so I don't need to explain. And then all the brand is going to have a RISC-V from 12-inch all the way to 16-inch. So, and next year, once the SoC is a good power performance, and with Tenstorrent, with SpaceMip, so we're going to fulfill all the lines with a RISC-V, from the kids all the way to the hardcore professional 16-inch. And then 2005, the first generation, we're trying to, because I need to test out the whole framework collaboration, so we made a very cheap one. This is the BOM is around, with the DDR increase now, now the DDR is just 8 giga DDR is $30 now. It's a crazy price. So this is around $150 BOM. So, and from after the framework collaborations, so we take a look at the hardware side now. Because the RVA23 announced, we have a problem of all the old chips, what to do with it. So we have a RVA22, which is space MIPS with vector. So what I'm going to do, we start making a router. So you guys can really open source latest software, loads of security patch with OpenWRT router with RISC-V, very A-core performance. And then this is the RVA22 with AI focus. It doesn't have vector, but it has a very strong MPU. And then RVA23 is coming back time next year. We're going to have chip back with December, and the ball out by EVT ball out sample before FOSDEM. And then when 2026-04 announced, we do another announce here, probably, you know. So the kernel upstreaming is what we're going to do. This is most important for the thing. And then AI is, you know, with vectorized come in, and then I think the major extension will be ratified this year, hopefully. And then the year, I think where we the end of the last year might have seen major extension for AI. So which is, and then as I say, we have a term called MNO, so most notified. So you guys can help, definitely can help. And then make RISC-V faster and faster, even on the whole hardware. And this is the router. So, and we do a evaluation. We're going to beat all the Broadcom and Qualcomm. They're still running 4.1 kernels. Okay. So, and this is what is now. It's 2006. We have 8 core 2 gigahertz, 64 DDR. So, and lucky we buy a few DDR, so we get rich by selling out the DDR now. It's selling out RISC-V board. So, and this is what it looks like. It's the first RISC-V chiplet. I don't think ARM has done chip that yet. So this is the first on RISC-V. We hit a lot of problems. And this is the current state of it, of our board. One 6 kernel, and then you can play around with all this AI, and then it's not optimized yet. So if you optimize paper, probably even faster. So what else we need to do? And RISC-V, there's a problem with RISC-V. So because we don't do Android, we don't do Windows, and we cannot scale. The chip is very expensive, and existing market is really hard to compete. But we decided, as I say, our slogan is tending to we make the best Linux machines, just because we upstream everything. So Ubuntu is going to be part of the rise. We're looking into next year, we're going to send 10,000 pieces. The year after, probably 100,000 pieces, just for Linux users, for all the developers. So all the software optimization really had to give it back to Ubuntu. You guys have all the expertise to help us to make the history. So we have 20 million for Linux users. I sincerely hope that we can get 2 million. That will be a 1 billion worth company for RISC-V. Then I can buy off the GPU open source. So, and I'm a British as well. So you know, in UK we have a few GPU company. And we look at it. Linux is one of the things I know is a certain market. I think the trend of RISC-V, and we do a startup, we need to set the start line and same as all the existing player. So all I can think of, we can compete with ARM. The only thing left of is AI. You can see the AI, my friend's doing another ARM board for framework. I look at that chip, the AI is not any better than us, RISC-V. So we see that AI is probably our all-in stage. We get we on the data privacy. We got the local AI running. So that's we're trying to do, two sides, Linux and AI. So yeah, as I say, you can see it's sad things, but I see it as an opportunity. Remember 30 years ago, Linux? Anyone play with 1.5? Anyone play with? I was the guy doing the first 2.6 kernel port on phi scale, the first ARM11. So I know all these problems. At that time, kernel a problem, GCC 3.4 is called problem, and our Java VM have a problem, and the chip have a problem. So exactly the same, no surprise. So, but everything very interesting. So that's the status of it. And then the coming schedule is very exciting, right? Hopefully you guys can, I'm still trying to hit 2604 Cindy, make it happen, mass produce. So, need you guys' help. I'm a very small company, I only have 30 people. But I got a very good support line, Heinrich, Emil's, and Cindy's team. And the most important, free of charge. Right. And exciting as well, we also get a 32-core build server orange. So, and now we officially can build RISC-V on RISC-V. So same time frame, and 16 core, and then with 12 core as well. So it's very exciting, I say next year. So that's why I do framework. I can't make my own laptop anymore. So I'm a software guy. Now this is a joke. I'm sure, you know, Canonical, a very serious software company. It's time to do hardware again. And probably do the chipset again. So, and my crazy idea is to do a AI phone again. So I have talked with Maru saying, I'm sick of parking apps. I travel around the world. Each city have 3 parking apps, at least. If London, probably every council are free. So you can see. So I hopefully one AI phone can help do all the things for us. That's just part of the fun of RISC-V. So open source everything, AI everything. We don't need to have screen anymore, just do the work. So this is so hopefully, you know, Mark can see this and start doing the AI phone again. But this is going to be successful with RISC-V. Well, and when I look at the phone, the reason why Android is so successful because the SoC is the bottleneck. Now we're making RISC-V, the SoC is primarily for Linux and open source even before the chip out. So Ubuntu basically can make any hardware. All right, and then because we have so many problems on the software side, we announced 100 open source community projects. Whoever contributed on, we give the hardware for free. Okay. Thank you very much. And that's it. We can get all you guys. I just came back from the RISC-V Summit all over America. And then we have a first ever time we do software workshops. So hopefully you guys contribute more. We can do workshop along with Canonical's all the meetup events, and we talk about how you guys contribute the real open standard open source CPU. Thank you.
Perfect. Thank you.
Thank you very much.